All right, good afternoon, everybody. Thank you and welcome. Thank you. Welcome to our Twitch audience. Thank you to everybody for being here. If you've stayed since the last panel, thank you. I'm going to introduce an incredible graduate to you guys. He graduated in 2008 from game development. He's currently a senior gameplay and systems engineer for Gearbox, which you obviously know, which is why you're here. He will do a presentation, and then we have a mic in the middle, so if you have any questions, please use that after his presentation. And on Twitch, if you guys have any questions as well, feel free to type it in there, and we will hopefully answer them all. So, doing a presentation on data-driven games, please make some noise for Jason Brown, everybody!
How's it going? How's everybody? So, hi, my name is Jason Brown, and this is going to be a talk about data-driven architecture in games and how the heck we actually shipped a billion guns. So, let's go ahead and get started. All right, so first thing real fast, if you are looking for the art creation pipeline, there's going to be at 2 o'clock with Jacob Christopher. And if you were looking for the Fat BTO talk that Josh Davidson just did, that was at 11, sorry. So, who am I? My name is Jason Brown, but first I kind of want to find out really fast who all of you are as far as degree programs go. So, game dev students, can you raise your hands real quick? All right, and then just game relevant programs. I know there's a lot more of that. Ooh. All right, if you are not tied to a games program, but just here to hang out and hear me ramble, literally no one. Nope, 2, 3, sweet, awesome, welcome. Okay, so, like I said, I'm Jason Brown. I graduated game dev in April of 2008. Started working pretty much immediately after, and I just have this wide breadth of experience from working for a smaller company and then moving on to Gearbox. I've done AI work, I've worked on gameplay. Let me get over here, here we go. Gameplay, I was a lead programmer at my last studio. I do a lot of systems work, which is not necessarily engine, but more back-end type stuff where, you know, it may have to talk to, you know, back-end servers and that type of thing. Usually hooks into gameplay. And then UI most recently has been some stuff that I've been doing. So titles that I've worked on, I worked on the America's Army titles. I worked on some for 2, 3, and 4. I was the lead programmer on 4. And then I came to Gearbox and worked on Battleborn, and then most recently, Borderlands 3. And then my main character I just finished the game with is Zane. Yes. So, who's Gearbox Software? If you haven't heard of us, we're an independent developer. We were founded in 1999 near Dallas, Texas. And some of our titles would include Brothers in Arms, Battleborn, which came out a few years ago, and then the Borderlands franchise. So there's a lot of people that obviously work on the game. For the code sections of the game and a lot of the stuff having to deal with the guns and loot and stuff, from the code side, these are the 4 biggest contributors. So I just wanted to call them out and give them credit. They did a lot of hard work to get the guns as awesome as they feel. So another quick disclaimer. Data-driven architecture is a tool. There are lots of other tools. This does not mean that you have to go run back and retool your entire final project 2 months before graduation or something like that. So, there are other ways to do things. This is the way that Gearbox really likes to build stuff. A lot of our systems are built off of data-driven architecture. The gun system, of course. We also have the enemy system and how a lot of them are put together. The Malawan army is very data-driven for a lot of the pieces and the parts that show up on them. The mission system is a data-driven system. Our designers can move objectives around and change how that stuff's linked. It's a more kind of directed system because obviously you're stepping through the missions and everything. It's not quite as random as the guns are. Challenge system, the same way. You define a lot of data. You know, the game looks for that data and those events to happen, and then it moves along. Combat, you know, we have definitions for what particular set of things can spawn in a given area. And so those can be plugged into a lot of different places. I'll talk about that in a little bit. So we use this system a lot. This is a very different way of working as well. When I came to Gearbox, this was kind of a whole new thing for me. This is not how I was used to building games, and certainly not how I had heard a lot of stuff taught in school, which is why I wanted to talk to all of you. So, data-driven architecture, just why? Why would you do it this way? What's the primary motivators? So what do we care about at Gearbox? Why is it that we've chosen this? What is it that we care about that makes this so important to us? So the first thing is flexibility. So we want systems where we can put things together quickly and easily and also be able to kind of take systems and bend them some without having to worry about retooling an entire pipeline because a designer want to make some changes. Scalability. 1 billion guns. That is scalability, like the best definition I could possibly give you, right? So we need to be able to have stuff that can scale out to massive, massive numbers and be able to manage all of that content and everything. You know, loading in all the parts to make 1 billion guns possible and have that loaded into memory takes a lot of work. So a low barrier for new content. When our sound designers, our artists, the guys that model all the weapon parts and stuff, when they bring this new stuff in, they don't want to have to spend a day to kind of put this stuff into the system somewhere. They want to be able to link their model up into one place and have that thing go and be able to see it in the game very, very quickly. And then reusable. So talking about the spawn definitions and stuff, if a designer creates a particular set of spawns they really like, where maybe there's a few melee cycles and a few of the heavies and then like 1 or 2 snipers in the back, if they have this kind of definition, they may want to be able to reuse that in places. They don't want to have to hand tool each one of those places every single time. So that's a big thing about reusability and portability, being able to take those definitions and move them around. So what is all of this data? I keep saying the word data, and I've kind of hinted at what some of those things are, but when you come along and you have something like this, right, there is a lot of data being shown here, okay? So we've got obviously the animations that you see for what's going on here. There's all the meshes and stuff for what's going on with Amara. You got the textures and the materials going all over the place, the audio that's going to play when this comes along that's going to be firing at different points in the events, the effects, the rings and the stuff that are coming off here, all the electricity going through the air. But then also the design, and this is one of the things that sometimes gets forgotten. The design is data. How long does this thing fire for? What's the range? Is there an impulse that's going to throw everybody back? What is all that data? How can it be used and tweaked and modified in really simple and easy ways for our designers? So don't forget, the design is a lot of what your data is going to be. So let's run through an example so I can kind of give you an idea of the scale of the problem we're dealing with. So we have an ADDY assault rifle. So for this, you're going to start off, you have 3 different barrels. You got 3 different barrel mods. You got 4 different rails, 3 different body mods, 3 different bolts, 5 different foregrips. I can keep going. 3 different magazines, 3 different scopes, 6 grips. That is a lot of different parts that can all combine together. And when you just multiply all this out, there's also 3 different fire modes that just don't have an art representation that also go in. So you get 262,000 possible combinations for one manufacturer for one type of gun. This is how you start heading towards 1 billion guns, right? So how do you put all this together? How do you manage it? How do you get your designers and stuff to do with it? So if I was a student, if I was coming out of here, if I was at my last job potentially, this is probably where I would have started. We have a gun class. That's the parent class for all this stuff. And then, okay, we have a shotgun, an SMG, and an assault rifle class. Cool, okay, this is making sense. This is a lot of definitely what I learned in school here and elsewhere. This is a very common way for us to think. This is object-oriented, right? So then some smartass comes along and says, well, I really want a gun with legs, right? How does that fit into this now? What do we do to try to fit that in to this architecture that we've started to build? Now, right now, this is not a data-driven architecture, right? So now we've got a shotgun with legs and an SMG with legs. And you can probably see where this is going to go. Yeah. And then what happens anytime you need to make a tweak or a change to how the with legs part works, right? You're going to all these different places. This becomes starting to become immediately a nightmare, right? So put the data first, right? And of course, what I mean is the data is the substance that you're trying to pull away from the logic. There's the doing and then what you're doing it to. And sometimes that doing can be represented in data like an operation, like math operators, or some given behavior that a gun or something may do. But the point is you want to try to get what you're doing away from how you're doing it. So one of the cool things also, data can link to data, right? So if you have a spawn point or a gun mesh or something, and that can link to other pieces. That spawn point could lead to a spawn definition that's just a collection of other spawn definitions and stuff, right? So there's a lot of things that you can do there. So data's plug and play. It's great. Like I was saying, if the weapon modeler goes in and creates a new barrel mod and he wants to get that plugged in, he just goes to that section in the data, and in our tools, he just adds a new entry to a list, plugs that thing in, and here you go. Like it's ready to go. So I'm going to come back to this later, but really important, remember factory models. There's a big thing about how the data and the factories can go together. That's a really strong point to be made here. So as an example, we have Mayhem Mode in the game. This is a late game thing, spoiler alert. All of these different things are just pieces of data. And this is one of the UI pieces that I worked on, so I can actually talk to it a little bit easier. There's some data sitting in the back end for what does Mayhem level 1, level 2, level 3 mean. And all I'm doing is just reading that data out. And if that designer wants to go tweak a number, I don't have to care. And that's a really important thing. And then all these modifiers are just in one big list, hiding in data somewhere. So when they decide, you know what, I want a new modifier that enemies drop 50% less cash. Okay, fine. They go build that modifier out. They go plug it into a list. And that is now discoverable by the system. And then when the Mayhem modifiers roll, hey, maybe that one will come up. So how do you get started on this, right? Like, okay, I'm saying a lot of words and stuff like, what do I do when I actually want to sit down and start building some of this stuff out? So understand your data. Understand what you're trying to represent, okay? If you're trying to build like a door, what are some interesting pieces of information about how that door operates that you can just pull away from the rest of what makes a door, right? So start with flat data structures. If you're building a projectile class, right, you got a rocket launcher in your game, just get some really simple data right there. You don't need some big hierarchy or anything else. Just what makes a rocket, right? And start defining that. And then if you start having other projectiles in your game, sure, maybe you can have a little bit of inheritance in your data, right? So then your rockets can explode and have a radius and have a different behavior, and maybe they take some time to travel. Maybe some other projectiles have a completely different behavior. But the point is start simple. Just start with flat data structures, stuff that's really easy to read and parse, stuff that you can very quickly iterate your code with. You can store data a ton of different ways. Okay, so binary data. This is the simplest, and like if you're using Unity or Unreal or something, this is literally just data assets, right? You've gone and defined some value in a structure or a class somewhere, and it's exposed in that particular editor to you, and then you can just go in and modify what those values are, right? You can also use something like XML or YAML. Another project that I've worked on, we used YAML. So all of that data was sitting in files, and we would just go modify that, but it was extremely designer friendly, right? If you've ever used XML, it's got a lot of markups and stuff like that that you kind of have to know. And there's some editors that can make that easier. We chose to use YAML because it was really friendly for the designers and also really easy for us as the coders to work with. Plain text, right? I mean, in your student projects, for example, you guys aren't building these massive games, right? And text parsing is obviously a skill you need to have. So if putting some stuff into a plain text file and just reading that in quickly and easily gets you where you need to go, great. Choose the tool that makes the most sense for you. Spreadsheets are another thing that you can do. The Unreal Engine has a tool where you can actually take those things in, they get read into tables, and designers can go work in Excel. So let's get on to factories. Factories in the real world understand a lot about the thing that they are producing, right? They understand that they have to have a particular set of machinery, and you kind of have to go through these very particular steps, step 1, step 2, step 3, to kind of build what that thing does, right? So the guns factory absolutely understands in our game, how do all these parts fit together and how does it work? It understands at an extremely high level, though. All the little individual data is further down into separate factories, sometimes parts factories, right? So your factories are going to consume the data, right? At some point along the way, this data here that you've got is going to get parsed into the game somewhere, sometimes into another structure, and then that's going to get fed over to your factories. So it's going to consume that data and understand, what am I making? What am I doing here? Okay, I'm a projectile factory. What's the information about the projectile? So it's going to understand what that data is. You're not just kind of blind feeding and just hoping that your factory kind of understands how all this stuff gets put together. A projectile factory understands, okay, I'm going to have a mesh. I'm going to have some audio. I'm going to have an explosion that's going to be associated with me. And I need to go read all these different pieces of data, look for them, and start stitching that stuff together, right? But the important thing is, you're not building the entire rocket launcher out of this thing, right? This is just one piece of it. When you click, the factory's the thing that's pumping it out, right? That thing can live separately from the gun itself as well. You don't have to have these things coupled together. So they could produce components, right? So gun parts, for example, and you can have more specialized factories, and that's a really important thing here is, in order to, say, produce a gun with legs, the with legs part can have its own factory. And that factory can sit there and do the with legs bits that it understands, maybe some animation information, or maybe some nav mesh information, or something like that, that the entire rest of the gun system doesn't ever have to think about, right? It's these really, really small components that stitch together. Object pools. This is another topic unto itself that I could spend an hour on. But the important thing here is that if you're dealing with pooling and stuff, you could have factories, again, for gun parts or projectiles, where at the beginning of the game, you're like, you know what, the player's going to be shooting stuff. I should go ahead and spin up a pool of 100 projectiles just to sit in the back and be ready, so you're not sitting there waiting and trying to create this stuff and potentially slam your memory in the process. Spawn limits are another thing. So back to the enemy design example, right? Maybe we don't want 500 skags spawning across the entire area, right? So you got all these spawners and all this stuff set up. The factory might understand, hey, you know what? They asked for a skag, but we've already got like 30 of them floating around the world. We're not going to give you any more. Sorry. And the game's just cool with that. And nothing else has to understand how that particular part of the system works. So that's kind of the relationship between the data and then how those factories are going to produce that data. So, an example, right? We've got a manufacturer. Some of the data for that manufacturer would be a list of the different weapon types that manufacturer has, right? We got 7, 8 different weapon types in Borderlands. Different manufacturers don't cover that entire set of them. Like DAL does not have rocket launchers, right? Or heavy weapons. Okay, so then in those weapon types, what's the base body mesh, right? That's the one piece that kind of everything else has to build around in our system, right? What slots are available on that thing? So Hyperions, for example, have the shield that deploys out, or again, the TDRs have the legs, right? So they understand like what things are available, what types of slots do I have? Maybe what are some base stats, right? What are some behaviors that kind of belong to this weapon type, You can start including that in there somewhere. A shotgun, some of that information could be here, or it could also be in the parts, right? And then projectile definitions maybe, right? And so, I'm this type of gun. These are the types of things that I can shoot. Maybe there's a bunch of different types and it picks one of those, right? And then, so from the weapon types, we had the parts, and so this is some different ideas of what those parts are. Barrels can contribute towards damage, grips can contribute towards accuracy, right? And then all of those stats get accumulated together to decide what the final stats are for that gun. But those are all individual pieces and parts that are all just getting pulled together and discovered by the system and then put together to make one cohesive looking gun. So, let's apply this real quick, right? You go fight this guy, right? He did. And loot explosion, right? This is what we all want. This is what we want to see. And when that happens and that loot explosion happens, we're deciding what types of things do we want to make, right? Like there's a loot explosion factory that gets told, I want you to make 3 guns. I want you to make 2 things of currency. I want you to make, some ammo and some health and some other things, right? This is all just data, and that thing just goes through that checklist. It's like, yep, I'll make that. Yep, I'll make that. And it's just calling out to other factories, right? And so one of those factories is the gun factory. And so you get this guy. And that gun looks a whole lot different than the one I showed before, right? It's got a whole different set of stats, but it was all assembled by the exact same system by just taking completely different sets of data randomly and then getting them put together in a way that made sense. Okay? So When that thing spawned, it had a data table somewhere. This is the data I'm talking about that can live in a spreadsheet. This is data that can live in plain text, right? This is just indicators that say, hey, here's all the different manufacturer types that we've got in our game, okay? And then they're gonna define, like we showed earlier, this is the different stuff. We don't want rocket launchers. And so it says, okay, let me go pick from this list, right? And then rarity is something that gets applied on top and separate from all that. Rarity defines how many different parts are allowed. You know, what are the range? Common only allowing like maybe 1 or 2 parts, whereas like an epic will allow like 5 or 6 parts to get applied. That's why they look so much bigger and better, and they've got a lot more stats and stuff. Again, that's just data. So like these different things, common, you know, rare, epic, they're just saying how many parts do I think should be allowed to get attached to this gun, right? So then we decide, okay, we're gonna build an assault rifle. So we're gonna go find that piece of data that says assault rifle. What does that thing define? Okay, it defines a body, it defines the body mods, barrels, and so on, right? Like, it has all of this stuff stored in there, right? But it's all, again, it's all just one thing referencing another, and all tied together with factories helping bring all this stuff alive. So, putting this all back together now. Understand what your data is talking about. Are we talking about guns? Are we talking about spawns? And a lot of this can also be the data for how's the user going to be doing this stuff, right? You have to think as game developers, a lot of times, especially as coders, we're not always building for the customer. A lot of times we're building for designers, we're building towards artists. Other disciplines that we work with, they're kind of our customers for a lot of the stuff. And so the way you build your stuff and the way you define that data and allow them to work with that data may have more to do with them and how they work and how some of this stuff flows than about necessarily what the customer might see. So, again, build your architecture around the data. Figure out what component part makes sense. If you don't ever need to separate, like, you know, the hinges on the door don't need to be a separate data asset if you have absolutely no intention of doing something interesting with those hinges, right? Like, that's not a useful piece of data, right? So there's no point in architecturing that around into your data, right? You don't have to go nuts and then, you know, explode every single thing out, right? Break it just into the component pieces that make sense. Use the factories to spawn the data, right? Again, factories are extremely powerful. They can know a ton of stuff that is very specialized towards that, right? A box factory knows how to build boxes. Nobody at a box factory knows how to build car parts, right? Same thing applies for games. In that kind of object-oriented model, think the same way that factories would apply here. So, that's data-driven architecture as best I can give you guys in a high-level notion, right? And we're going to have Q&A. Please ask me as many questions as you want about that. But I also want to take some time to talk about just tips as a developer to all of you as students, right? Like, just what is some useful information that I think I can pass along to you guys, you know, both as future developers, hopefully, and just as students now. So, let's get into some things. Tips and tricks. Use your tools. Know your tools. Know your tools extremely well. Artists, this tends to be more common. You guys know your tools a lot better a lot of times than programmers that I'll see. I've seen 15-year veterans using Visual Studio the same way a first-year grad student does, where they've just kind of used the very baseline stuff in the front. Some of these tools are extremely powerful, and the more you know your tools, the more effective a developer you're going to be, the faster you can be, the faster you can hunt down problems in your stuff, the more optimized your assets might be. So, getting back to data for a second. Strings are awesome, right? For storing data and for being able to edit it and manipulate it and define what that information is, strings are great. So you can, you know, write out words, because the thing is you shouldn't be trying to parse these strings at runtime. The second the user clicks and we have to go run off to the projectile factory, you better not be opening a file, right? And starting to like read through that file and decide, well, what was I going to spawn again? What does this mean? That should have been loaded up when the game started or when you loaded it into the level. Some other point other than the middle of combat, right? Strings are evil for stuff like that. But for storing data and then parsing it and getting it into fast, optimized stuff, they're really, really effective. So, repetition is the devil. Now, this can be said for a lot of different disciplines. For code specifically, If you find yourself, or if you're an artist and you're writing a script or something, there's functions that exist in some of those things. So if you find you're writing the same code over and over and over and over again, right, or you're copying and pasting it around, turn it into a function, make a helper library for yourself or something. Because the thing is, the second you discover you've done something wrong there, you're going to go repeat that work in all the different places you put that, and you're probably going to miss a few if you've done it a lot. Clear code flow. This is really, really important, that if you can tell me exactly how your code is going to move and what happens, then this happens and this happens and stuff, then I know you understand how your systems work. If something breaks down, you know where to go look and find it. Way too often, we really love building these big, complicated pieces of machinery that looks like some kind of Rube Goldberg machine, right? That's not effective in most means. A lot of what runs that entire gun system, we could sit down in the code and I could walk you through what a lot of that looks like very quickly and simply, right? So the cleaner that your code flows, the more simply you can think about it, and also shows that you probably have a better idea of what's going on. So refactoring, this goes to clear code flow. If it starts becoming a mess, right? If you have the time, and that's the really important part, don't refactor the day before you have to turn something in, or the day before a milestone or something like that, right? That's probably not the smart time. But if you've built a system out and it's working one particular way, and you and the designer or the artist start having a discussion and it's just not working away, instead of trying to attach some weird stuff to it and change some foot code and some functions, and it starts flowing all kinds of weird ways, spend some time and refactor it to make it work correctly. You will thank yourself down the road. So, moving on to testing. This is a huge, huge thing, right? Test with your actual game data. You don't have to do it at first. But before you're going to say, I'm done, actually take some real pieces of art and put it into your system. Sure, it renders a cube fine, maybe even a teapot fine. But the second you throw a psycho mesh at the system, maybe it falls apart, who knows? But you can't know until you actually try it and test it. Right? Test your tools as a consumer, okay? And this is, again, the consumer might be your coworkers, it might be the final customer, right? Sit down and use it. If you're building some UI and it's a form that you're supposed to fill in, go use it, fill it in. If this thing doesn't work right, if tabbing jumps you around to weird places or just doesn't work correctly, try to take the time to fix it. If you're building something for your designers, okay, sit down and try to actually design a thing that they're gonna make, and see if it works for you. Because chances are, if you can't figure it out, they certainly won't be able to figure it out. And if it's got bugs and problems, you'll find it through that testing. Debug commands. Debug commands are priceless for everyone, right? These can be command line things that you can run when the game starts. These can be things that you open up a console and you can type some cheats and stuff into. These are invaluable time savers, right? They can help you get any of your developers into a state very quickly. We've got a cool thing called Bug It Go, where somebody can record a location where a bug happens, and then you can go teleport yourself across to the exact spot at the exact orientation that something's at, right? Test environments, right? So if you're building an AI that has to, execute some jumps, and it's supposed to be jumps of varying widths or varying heights, right? Build yourself a map with a ton of different jump points in it, and let a bunch of bots go across those jumps. And this is not only important for the moment that you're building the feature for the bot to jump, but this is also important maybe a month or 2 months down the road where you had to make a change to how that bot jumps. And now you should go back to that test map, and you've got all your nice test cases laid out right in front of you. You can see, okay, did I break something when I had to go fix that one bug over there? Logging. This is another really invaluable tool. If you're trying to figure out a problem, something's not working right, something's not flowing right, why is this math wrong? Why isn't this damage happening what it's supposed to? Go write yourself some logs and make those logs tell a story. Don't just, copy and paste kind of the same stuff everywhere, especially if you're trying to figure out the flow of things. Number them if you need to, right? But don't make your logs take longer to understand than you trying to understand the problem itself. Use them to get you a lot of help, right? So, for the students, portfolios are great. Artists, portfolios are ubiquitous. You have to have a portfolio, of course. For coders, when I was coming through here, there was no code portfolios. We didn't have those, right? We just had to be able to talk about what we did. Now I see more and more students that apply that they have portfolios, they have websites and stuff. They're showing off chunks of their game. They've got code, they've got code depots somewhere where they're hosting some project stuff that they've done. That's great. But show what you did on the project, okay? I was very proud of my student project. I'm sure you guys all are too. But the thing is if I'm trying to hire you, I need to know what you did on that. So if you've got a montage video showing some stuff, call out what you did, okay? You don't have to be a video editing master to put some text on there somewhere or put a short description alongside. That way when I'm looking at it, I'm understanding what did you contribute towards this? Because I'm trying to hire you, not necessarily your teammate. Okay? There's a time to kind of be, uplift your team, but then when you're trying to get hired yourself, I need to know what you did. Explain your thinking, right? And this again can apply to everyone, right? Why did you do the thing that you did? Why did you go down that particular route? Why did you choose this type of thing? If you decide to include a middleware for some reason into some feature that you were trying to build, why did you do that? What was it there for? Help us understand what your train of thought was for that. So this is especially for programmers. One complete feature is better than building a tenth of a whole game, okay? With some of the tools and the middlewares and the game engines and stuff out there, it is not hard to get a really simple, say, side-scrolling shooter, up and running, right? But the thing is if you're just doing little tiny 10% of all these little features just to kind of get something cohesive working, I mean, that's great and all, and that does have some value. But if you, say, built an entire particle editor, right, just to get some particles on the screen, or you built a terrain generator or something, and you carried that thing all the way through, where you can show me you've got sculpting and you've got where you can paint some textures and stuff on it, that is way more akin to actual game development. Very rarely, unless you're in the indie land, are you going to build the whole thing by yourself. Game development companies tend to want to hire somebody, and they're going to take on a feature or a few features, and they're going to own them from start to finish in a lot of cases. That's at least especially how we work at Gearbox. And so if I see that you've taken an idea and you've seen it all the way through to the end, and you've worked out that last 10%, that really hard last 10%, and polished it up, and you've got something worth showing, that speaks volumes. So, I think that hits my time here. So we've got about 25 minutes for questions. So I think there's a mic somewhere back that way. If you guys have questions, please come on up. I'll go ahead and switch this over. A little bit of contact info. If you guys ever want a message or try to get a hold of me, there's some info for me. I'll just leave it up.
You talked to us about some of the benefits and intricacies of data-driven architecture. Can you talk to us about some of the downsides or limitations to that development methodology?
Sure. So one of the big downsides, I said data can link to data, right? Trying to follow that entire string of data can get really ridiculous. Okay, in Unreal, which is the engine that we use, if you've got a data asset that then goes over here, but then someone's plugged something in over there, and then that data asset's referencing that data asset, which is referencing that data asset, and it goes like 10 wide, and you're trying to identify some piece in the middle, it can get hard to track down. That is certainly a downside, and so a lot of that comes down to just good organization. Right? How did you get this stuff structured, right? Because otherwise, if you just have a bajillion pieces of data referencing a bajillion pieces of data, you're going to start getting lost in your own data. And so organization is an important way to combat that, but it's definitely a slippery slope sometimes.
Thank you.
Mm-hmm.
Hi. So what do you think is the most important thing you've learned as a game developer?
Most important thing I've learned as a game developer. Probably a few things. So iteration is really important. Being flexible and willing to iterate with your team, not only having the capacity for your code to be able to iterate quickly, but also you being in the mindset. A lot of times when we build a thing out and we've spent a lot of days or maybe a lot of hard nights working on something and we're really happy with it and are really proud of how that is, it may just not be what the game needs. You may not know that until after you actually start playing with it. And that's a really big point, right? Some of the first iterations of Mayhem Mode were not necessarily where we wanted, but we were really crunched for time. But we spent the time to iterate it and get it working the way that it felt good for the game. So that's one point. And another kind of just goes to that is just being able to work with the team. being able to be a team player, being able to take constructive criticism, right? Game developers, we get really heated sometimes. And we get really impassioned, and we'll start, getting really excited and getting really loud about a thing. A lot of times, it's not me attacking you or your feature or a thing. We're just really trying to get the best thing that we can get out there. And so being able to take that feedback and process it, and a lot of times you'll just get some extremely loud people that kind of just say a lot of things. Being able to parse that feedback, especially as a coder, and figure out like, okay, how can I translate that to actual meaningful changes to get them what they want? That's a really useful skill to have.
Thank you.
Thanks. Hi.
I was just wondering, you spoke on the factory systems, and I was wondering, like, when you go on like a farm run during the game, like try to beat a boss or something.
Okay.
Is there something that goes into the factory system to make it like spawn like a legendary versus a common and all that kind of stuff, or is it just like you have to meet a certain criteria to actually get it to do that?
So that particulars of the game, I'm not sure about. So the thing is a lot of what I do is actually expose tools for the designers. And so like this is stuff that they get to go do and deal with. And a lot of the logic lives in their land. For that specifically, I mean, I think it's going to be some random rolls or something. I don't think there's a huge high-level system that's really like a playing director of loot, Do you have another question related to that? Okay, thanks.
What type of software or even online stuff do you suggest for someone who's trying to teach themselves to code?
So teach yourself to code. I mean, so there's the free Visual Studio version out there. There's a few different realms of Visual Studio. I don't remember, like there's Visual Studio Code, Community is what I'm thinking of. Visual Studio is more or less the tool for coders. The thing is, I mean, yes, it's a text editor, and it's also a debugger, and it has a lot of other really powerful tools in there. You guys are at a huge advantage. There are so many free pieces of software out there now, so many free middlewares. So, if you want to go pick up Unity, great. That's C#. You can go start diving into that, and again, use Visual Studio. Unreal, same thing. So those are some good places to start. I suggest mods a lot of times are a really good point to start, where you're kind of in some existing stuff because then you have examples to work from. There's also, a bajillion YouTube videos about basically anything under the sun. So hopefully that can get you started as well. Anything else?
No,
cool.
thank
Thanks.
Hi, my name's Patricia. I'm in game art, so it has something to do with this. It's more of like a two-question thing. So for us, I was wondering what would help the art department communicate with you guys on what you need? Like, would you give out a list, or how would you communicate with each department to emphasize specifically what you need? And the same for us, where like, would you ask us questions on like specific props or assets you need?
So at least at Gearbox, code usually doesn't make requests from art in kind of the way you're describing. That's usually coming through the design. Now, obviously that, can definitely happen, and especially if you were like an animation programmer, you probably have a lot more to say about how rigs are built and some stuff like that. The simplest thing I can say is, between any department, code and art or anything else, it just needs to be an open dialogue, And when it comes to things like budgets, I think, Jacob's probably going to talk about those some later. I mean, code needs to be very clear about what those budgets are. How many tries, how many materials, how many textures can you, fit into stuff. That should just be an open conversation. And a lot of times those budgets don't make the artists happy. And so like, that needs to be said, because obviously artists are trying to bring an artistic vision to a game, and coders are trying to get that to run. And so it's constantly kind of this back and forth, but, talk to each other. That's the best thing I can tell you, is just have conversations and try to figure out, how do we get your art looking as best as possible up on the big screen?
All right, perfect, thank you.
Mm-hmm.
Hello.
Hi.
Wow, that's loud. From our Twitch channel, I have a couple questions. Raz818 is asking, where would you use a factory versus a prefab like Unity?
Okay, so I have not worked with Unity much, but my understanding would be prefabs are something you're probably going to build in the editor, and at least with my experience working with prefabs, that might be something that level designers might use a little more often. If you, again, I'm not super up on the Unity side of things, spawning a prefab that may just be a collection of things, and it's entirely possible that a prefab is just the data or what plugs into the data, and then the factory would spawn the data that's referencing that prefab. And that's, again, if I'm understanding how kind of some of this stuff works.
Okay. And from Midnight 37, he's saying, is it looked down or harder for someone in their 40s to get in the industry compared to someone in their 20s? He's asking because he graduates game art next week.
Personally, I don't really think there's much of a downside. People would look down on somebody. You know, unless you've plastered your age on your resume and you've applied, you know, I'm gonna go look at your portfolio. Obviously, I'm an art artist. Jacob's gonna go look at your portfolio, and you know, can you produce the work? Can you do the job? You know, me personally, I don't care what age you are. I don't look down on it at all. If you can do the job and you are as excited to come to work as I am and do the same things next to me, great, perfect. That's really all we care about.
Thank you.
Thanks.
Hi.
Hi.
I was wondering, how did you get your first game development job?
So I cheated a little bit. It's not really a fair story. A former game dev instructor came down from America's Army, and he just kind of went on a recruiting trip. I'll say the part that I played on it is I jumped right on talking to him and some of the guys that came with him, you know, opened myself up, had conversations with them. They said to me after the fact that, you know, part of the reason they hired me was because I actually was willing to go talk to them. So, you know, this is one of those times, guys, and I'm not saying I have time to talk to all of you. I really, really wish I did. But like, you know, if you have a real question and you want to come talk to me after, please do so. Do not be afraid to come talk to me. It is fine. Do not be afraid to reach out later. You know, if you know, there's too many people and you still have that question, reach out. It's fine. So it's kind of like putting that foot forward was kind of like my part of what I did. But yeah, and then after that, it was, you know, I was willing to accept maybe a less than glamorous job. You know, I was not going to go work on the next Call of Duty or go work at Blizzard or something like that. You know, those are all the types of jobs that I know we all aspired to when we were in school. That may not be your first job. But the thing is get as much as you can out of that first job, get as much experience as you can out of that first job, and then give yourself some time to go look elsewhere. Don't be picky, basically, because it is a competitive industry.
Thank you.
I hope it's okay if I ask 2 questions. No? Okay.
No, come on, yeah.
So it should be a pretty quick one.
No, go ahead.
How important do you think it is to anticipate the needs of your designers as somebody who's creating tools for them?
So that's actually a really good question. That is a dangerous thing to walk across. I mean, you should, let's be clear. You should try to anticipate their needs. Again, kind of like what I was talking to, be the consumer, test their stuff, right? Like if they're trying to spawn an enemy, start thinking about what some of those things are. And sometimes designers are not the best at getting all the ideas in their head out on paper or out verbally. That's fine, we're all human, we can't always completely communicate what we're looking for. So like, use the tool. If you feel like there's absolutely something lacking, great. However, and this is the other side of that that's really important, don't go close yourself in for a month and build this giant extravagant thing that they're only gonna use 10% of, right? Make sure you're building towards what they actually need. Talk to them, right? Again, it should be open communication channels. So anticipation's great, but make sure you're actually building what they want and you're not just attaching a bunch of extra features that they didn't ask for and have no use for.
Hi, my name is Cameron, and I actually really wanted to ask you a question about not only communication between artists and coders, because I know a lot of the times, especially in my experience, like once the water gets muddied, it's just a mess, and it's hard to clean up. It's just and also, what are some of the common tools you guys use to help give artists like a better edge, or something that you guys use to communicate in order for the work to get to the level that we see before us?
Could you clarify your first question a little bit about like how to keep people talking? What are you asking there?
Okay, so I mean, like sometimes it's like when you're an artist, and let's say you're a character artist, and you have like a fully modeled character, and it's all textured and ready to go. But let's say there's like like a constraint or something in the code or something that they can't like necessarily do because the character model just wasn't built that way, or it's just something like the character modeler might have forgotten and stuff, but like no one can communicate that missing part, or in other examples just like textures or like something like that.
Again, I mean, it should be an open dialogue. So if you've built the thing out and you've maybe used, say, a particular feature of Maya or something, and it doesn't work, well, I mean, and you're loading it into the game, or you get the coder to get it load up, and you're like, that's not right. Like, start working on it together. And it's going to be that push and pull. What do they have time to go in and support? Again, how can they help you? But then at the end of the day, I think we all wish we had more time to devote to try to get the art looking better. But there's always that cutoff. And that's just something like we all just have to acknowledge at some point or another. But again, that kind of goes to my iteration point as well, that you need to be flexible enough to kind of turn stuff around. And if your thing isn't doing exactly what was needed and it's not for the best part of the game, well, then maybe you as a coder should kind of be rethinking what that means. But I mean, again, talk to each other. Just talk. Cool. Thanks. Hello.
I'm Abby. I was wanting to ask about like after production, like that time from when production ends to when the game actually releases, what is the team doing? Are they polishing it still, or is it completely done and everyone just like silently waits, or like what exactly is happening?
We all go on vacation. We get on cruise boats and we just sail around the world till it goes gold.
I imagine.
Not at all. So yeah, it all kind of runs in different waves and stages, right? So concept artists are usually way before your regular production and everything. And so when production's winding down, for example, your concepts artists are usually rolling onto, let's say, DLC. Your production team, all of your content developers, right? Your character modelers and your environment modelers and your level designers and those folks, they're probably thinking about the next thing. The best run development is the one where all those teams are kind of sliding around. Coders tend to be really, really necessary at the front, and then really, really necessary at the back. And so I could say, like, for me personally, I was working on bugs all the way up until we certed with the first parties, Microsoft and Sony. And then I was working on day one patch bugs and stuff after that. Coders tend to stay busy the whole time, but there's definitely not a, okay, cool, everybody go home, we're done, guys. But yeah, it just depends, and what's the next thing, right? Is there another game that, is coming out? If you're a place like Ubisoft, the answer's probably yes. At Gearbox, I mean, yeah, we've got DLC coming, so they're hard at work on that.
Awesome. Thank you.
Mm-hmm.
Hi, my name's Ryan. I was just curious about what do you suggest to students that game development students that are starting next week, next Monday? What do you suggest for them to do to get prepared to prepare themselves for the industry?
So you actually haven't started yet. You're starting next week?
Starting, yeah, is
all right.
The orientation week.
Oh, nice. Good luck.
Yeah.
So this applies to all of the degree programs. The first thing I told people, and I used to actually stand on stage for new students when I was a student here towards the end of my time, and the same thing I said then applies now, and that is you will get out of these programs what you put into them. So, sometimes you're going to have those classmates that, when it's the weekend, they may want to go bounce off and spend the weekend downtown or Disney or whatever. That is important. Don't get me wrong. You do have to keep a quality of life balance in there somewhere. But there's definitely some of the people that are like, okay, I did the class, I did the thing, I'm ready to go home. And then there's other people that are like, well, I really like that thing that I got taught in my AI class. I'm going to spend some time in my free time and like keep working on that thing. Or I'm not super happy with how that project finished out. Like, yeah, I got a decent grade, but I'm not happy with it. I'm going to keep working on it, right? That's one of the big points I would say is just, put the effort in because, you're going to be spending a lot of time here. And so, you should be coming out of here and look back and say, yeah, I spent my time the wisest across my time at Full Sail.
Thank you.
Mm-hmm.
Hello.
Hello.
So I'm a designer, and I was wondering, at what point of the production process did you find out that this game was going to have potentially 1 billion different types of guns? And how did you react to that? And how did you immediately know that, there was going to be a way to do this without telling a designer no?
So I was probably not in the room when a lot of those discussions were had. We had basically a gun team. They were a multi-discipline team, and it was their whole job was to get this done. I can't really speak for them, and if they're watching on Twitch, they may get really mad at me. But I'll say I don't know that we necessarily targeted a billion. We just knew we wanted variety, right? And I'll say the designers and the artists really wanted to target having all those different pieces and stuff. And I think it wasn't necessarily like hey guys, this is what we're gonna do. Okay, how the hell do we do it? It was, we started adding a new thing. Oh, well maybe we can add a grip. Maybe we can do a barrel mod. I think we can get this thing in here now. And it kind of just started to grow in a way that made sense. But I'll say to those guys credit, they knew what they were doing, right? This is Borderlands 3, and there's actually 4 in the series. They probably understood more than a lot of the other teams about what exactly they were building going into this. And so they kind of had the benefit of, all right, let's look at what we did at BL2, and then, all right, how do we go up a step up from that? Obviously, the answer was putting legs on guns.
I'm sorry, I did kind of squidge in 2 questions into that, but my second part
Sure.
was, how did you realize that there was a way to achieve this kind of scope that the designers were asking for? And what is your thought process behind that?
It's kind of just an ethos across Gearbox that we try to build stuff in data-driven ways. And unlike my last job, where I was a gameplay programmer at my last job. I made the gun shoot, I made the character jump. It was kind of that very front customer-facing type of game development that I think we kind of all traditionally think of. When I came to Gearbox, I'm a gameplay tools programmer in a lot of ways. And so I think to try to answer your question, it's more about us building smart tools and empowering the designers. And then, quite frankly, all of this happens because we have some really smart game designers that took these systems and these tools and found these ludicrous ways to make it possible. And so with the designers, they just found every single place that they could just edge out every tiny little bit of features out of those tools. And so it was less about what the coders were capable of building, as far as the content's concerned. We just made the tools, and the designers were the ones that just went nuts with it. And they were the ones asking for this stuff. And so I think a lot of credit needs to go to those guys for just having the batshit crazy ideas to throw into this game.
So make the most out of your tools.
That would be a good takeaway, yeah. Thanks.
Thank you.
Hi, I know you said object pools were a very deep topic, and I was wondering if you could share any maybe best practices or design patterns you've experienced working at Gearbox that would help us gain some knowledge about that topic?
Sure. So pooling is great. I can give an example. So the UI in the game, you get all the different slots and all that kind of stuff, and you've got the bank page, right? The highly debated size of the bank page. All right, and each one of those things has a slot. And so those slots, when we were, months ago trying to load it, we weren't pooling any of that. We weren't spinning it up ahead of time. And so when we would say, hey, open the bank, it would take a little bit, right? And so then what we decided to do is, hey, if we go ahead and we know the size of the bank, that's fixed, we know what it is, let's just go spin up all those slots ahead of time. And then, oh look, it opens faster. So pooling is one of those things that you do it when you've got downtime. Excuse me. You do it while the game's loading, you do it while the level's loading. You get this stuff, and as long as you have the memory for it, and that's the big thing, is you can't just have a pool for everything and have them be huge, because, look how fast the game runs, but you're also out of memory and you're crashing left and right. So, that would kind of go to my point of understand what you're building towards, right? We only allocate what the bank can actually do. When I was going to figure out what that number was, because it was me that did it, I had to go find, hey guys, what is our bank size? I'm going to spin the pools up to that size, right? So that would be one kind of set of tips for that. Again, they're a really big topic, but they're also pretty simple to start with too, right? Projectile pools are a really, really common thing. If you got a game with a rocket launcher, get some rockets off to the side. The other half of pools that I didn't mention is after you use the thing, recycle it back into the pool, so you're just using that same memory over and over again. Like I said, I could go for a while.
Cool.
Thank you.
Cool, thanks.
All right. Hi.
Hi.
It's me. I missed you. Raz from 818 from Twitch is also asking, what's your favorite character to play? It's a very vague question. Oh, did you say it? Was he not paying attention? Oh, Raz 818.
No, it's fine. No, it's Zane. I was able to finish the game. Oh, wait. Ha! There he is. Yeah, no, I actually was able to beat the game the day I finished making this presentation 2 days ago. And yep, that's my boy.
Oh, is he your boy?
Mm-hmm.
Okay.
I love Zane.
Now I love him too. Anyway, that was awesome. At 2 p.m., Jacob Christopher is going to be here talking about art creation pipelines. And at 3:30, all 6 grads are going to be here. So please come back for that. I also have some swag to give away at 3:30. So trust me, you want to come back for that. But right now, let's give it up for the ever so fabulous Jason Brown, everybody.